Hi everybody. If you've been using a Keysight packet broker for any amount of time, you've probably noticed that we talk about network packets in ways that you haven't seen before. For example, if you look here, we're talking about layers 2 through 4 and layer 4 ports. Or if you look at some of our packet stack features, I go all the way from layer 2 through layer 5. Or layer 3 without IP addresses. Or in our documentation, you'll see sentences like this one here. I gotta admit, I had to read that a couple times before I understood it. So I'm Hans Hohenner. I'm a systems engineer at Keysight, and today we'll unpack a TCP/IP packet and explain what this is all about. So before we get started real quick word on TCP/IP and the OSI model. Many of the things we're going to talk about today, layers 2, 3, 4, 5, really kind of borrow the terminology from the OSI model. But that's as far as I'm going to go down this road. There's a lot of differences between the two. It's a bit of a rabbit hole on talking about that, so I'm just going to leave that lie as it is. And instead, let me go draw a picture of what a packet looks like, and we'll explore this topic further. The discussion for a packet broker really starts at the start of layer 2, which is right here, or the beginning of the destination MAC address. It includes the destination MAC, the source MAC, the VLAN tags, and remember, you can have more than one of these. The first one, from a packet broker's perspective, is the outer. The second one, if this field is duplicated, so you'd have another 802.1q field, would be the inner VLAN tag, and then the Ethernet type. The Ether type tells you whether it's IPv4, IPv6, or some other standard. The end of layer 2 from the packet broker's perspective ends right here. It's also the same as start of layer 3 or over here, except that if you specify the end of layer 2, you're ending here, and you can index into the payload of the frame. If it's not an IPv4, IPv6, and you know what the structure of that is, you can use that to your advantage. Other than that, start of layer 3 is the end of layer 2, and it actually starts with something called the version over here and a couple other fields. The first one that we really key on the packet broker is the DSCP and ECN for any quality of service filtering. The flags and fragment if you want to do any sort of analysis on how fragmented the traffic is on your network. The protocol, which will tell you TCP, UDP, some other protocols in what we collectively call layer 4. And finally, your source and destination IP address. Again, you can end of layer 3 is here, and if you wanted to index in the payload on your own and not worry about Keysight's marking of the fields, you can certainly do that. Start of layer 4, otherwise as end of layer 3, and it starts here with the source and destination port for both TCP and UDP. TCP also has the flags, so you can look at things like SYN, ACK, FIN, the various TCP flags you've got. And then you got the payload for either one. This here is layer 5, and it includes things like maybe your TLS or your SSL handshaking, any other protocol that you've got going on up above TCP and UDP starts here. If you got structured data, you can use that to your advantage and index after the end of layer 4 here. GRE, I'm going to cover just as a special case because the layer 5 portion of that, if you specify hex 800 in a protocol field in GRE tunnel, this is actually an encapsulated IPv4 packet. And so this encapsulated IPv4 packet is also what we refer to as your inner layer 3, because it's the same format as layer 3 here. If you did it as an inner layer 3 and you wanted your encapsulated source and destination IP addresses, this is what it would be referring to. This also is the same for MPLS and other tunneling protocols out there. So I hope that covers what layers 2, 3, 4, and 5 are from a Keysight packet broker's perspective. If you have any questions, please contact us at jointhejourney@keysight.com and would love to talk to you further. Take care.